Okay, hi everybody, this is Scott again. If you haven't seen the video on my profile page, I have another video in the personal project section of a low-res or low-resolution graphics plotter for the Apple II. My son and I here, Shane,
Hi.
we're working on a program together in machine language on the Apple II. And we're using that Apple plotter to help us draw some of the graphics we're going to use. But anyways, we're making a game called Hangman, and Shane's been involved with this as well, and he's learned a lot about hexadecimal and binary numbers. And so I'm going to have him kind of help me walk through this. She'll be my Vanna White, kind of like on Wheel of Fortune. Okay. All right, buddy, go ahead and put us into the monitor. Alright, so there we are, we're in the Apple monitor ready to put in some machine language code. Alright, we've already loaded, or should I say be-loaded, our text print process that we came up with, which is essentially just a for next loop that's going to have the machine language run through and address a section of memory that would print out the words press any key, which is going to be part of our title screen. So, you remember how to get the list to come up for the program we have? All right, type the number 1000, the letter L, and what you know as an enter key used to be a return key way back in the last century in the 1980s. There you go. All right. Let's see if I can keep this camera still. All right, so if you look at lines 1000 down through line 1001 echo, or E, that is a combination of our loop and our text. Right?
Yep.
All right, thanks, Vanna. All right, let's move on. So, we know machine language is pretty boring to look at, let alone having to listen to a video about it. So, I just want to kind of go through just the loop we have that'll read text using the offset with the Y register to call the different memory locations. So, it kind of works like an array in a sense. And the 5-line loop, if you remember, Shane, works out better for us because if we had to call each letter from memory,
then it would take up way more line space than making a continuous loop.
That's right. And the Y counter, or should I say the Y register, acts as a counter, which helps us build our loop. So, looking at line 1000, we preload the Y counter with the number 0. And then on the very next line, you'll notice that we're loading the accumulator, which is where all the magic happens inside this this old machine with the 6502 processor. But anyways, we're going to load the A accumulator with memory location 1011, where if you look further down the screen there, you'll see 1011 with the hexadecimal numbers D0 and D2, which corresponds to the letters P and R. But so on this line here, so we load up with an offset of 0 because Y is loaded with 0, correct?
Yep.
And what's the next thing we're going to do? Once we load the accumulator, we want to
compare
to
0.
That's right. So we're going to compare it to 0. Now, because we need to make this thing smart, we need to know when to tell it when our words end. It kind of works like the C programming language. It uses a 0 to denote the end of a string of text. So we compare to 0. What happens here?
We
branch
if not equivalent.
Yeah, if not equal to 0, we're going to branch. So if we pull from memory location 1011, we pull a D0, which is a letter P, we don't have a 0. So we're going to branch to 1000A right here, which then tells it, hey, I want you to put that character to the screen at memory location 0500 with an offset of Y. So we kind of use this Y register as for dual purposes here.
Yep.
We have it help increment the screen location as well as increment the location of memory we're pulling from to read the letters. So that's pretty cool. And then after it puts that letter on screen, what is it doing here?
It's incrementing
Yep,
the Y register.
right. It's incrementing the Y register, which is now going to be 1. Okay? Because if you remember, we started at 0. After we increment the Y, we have to tell it to start the loop over again because we haven't found the number 0.
So it's jumping
Right.
back to line 1002.
Right, where we start all over again. Our Y register has the number 1 in it. So the offset for loading the accumulator would be from memory location 1011, 1, which is effectively 1012, which is our next letter, being the letter R. And so it continues on. It'll just keep running the loop until it gets down to 1001 echo, where we encounter a 0, and we hit our RTS statement because we do equal 0, and we're done. And, oh, Shane, and I forgot to ask you, what is so special about the 6502 processor and how it stores the high byte and low byte for a memory location?
Well, with your numbers, when you type them in, it'll put the first number last and the last number first. It'll like switch them around.
That's right. And that's probably one of the hardest things to remember, right?
Yep.
All right. I think we might be boring our viewers because machine language isn't that fun. But it's kind of cool to show what we're doing. So this is going to turn into a final project eventually. We're running into some issues with disk access. It's hard to find the resources out there that really talk about how to talk to the disk drive from machine language. So that's all right. We'll get through it. We have the graphics plotted out. We know how we're doing the title screen.
And you have a Vanna White over here.
And I have Vanna White over here. That's right. So thank you, everybody, for watching. If you have any questions, please drop us a line. We'll be happy to let you know a little bit more about the project. That's it.